Hi everyone, this is Dr. Keith again. So let's keep going with our examples. We've made it through ERDs. We've learned about eliminating redundancy, or data redundancy in databases using relational tables. We've created these ERDs here in Lucidchart. You've practiced that a bit, hopefully had a couple days to work on that. And now it's time to go ahead and create this new database in Access. So let's go back to, let's use specifically our orders example that we've been using all along here. I want to create this database in an actual relational database management system. So go ahead and open Access. If you don't have it, you're going to want to pause this video and wait until you do so you can practice along with me. So when you get it open, you should see something like this. Now Access, like I called it, it's a real, actual relational database management system. Now, many things can be a database. A filing cabinet can be a database. A text document can be a database. A database is any organized collection of information. What makes a relational database management system is when you have added features for security, for making sure that you maintain data quality. We call these business critical integrity constraints. These are ways of ensuring that the data that gets into the database is valid and clean, good data. Access, although it is a real RDBMS, yep, that's the right acronym. Although it is a real one, it's kind of a low-level one, meaning that it doesn't handle massive amounts of data, but it can do all of the main features that a relational database management system can do. And so it's a perfect way for students to learn. And it's actually quite common in the workplace. It's not at all uncommon to export smaller amounts of data from your large organizational database into an Access database so that the average user can play with it a bit more, or vice versa. You could make an Access database to record transaction processing or something simple that is then later uploaded or integrated with a larger database. So there are a few things that are different about working with Access than working with Excel. First thing I want you to do is click here on Blank Desktop Database, and unlike Excel, before you can start editing anything, it immediately wants you to create the database, give it a name and give it a storage location. Why is that? Well, it has to do with the purpose of a database. An Excel file is not meant to be edited by multiple people at the same time. Now you can do that with Google Sheets, right? Or the online versions of Excel. They're meant to be edited by multiple people. But typically the purpose of a database is to be accessed by many machines or people at once. So for example, the database that records orders needs to be accessed by every checkout stand at a grocery store. Maybe everyone all around the world at every grocery store, so that they're all putting the data in the same place at the same time. Well, in Excel, if two people open the same file, let's say it's stored on a network drive, if person A opens the file and edits it, and then person B opens the file and edits it, which person's edits are going to be saved if they both save the file? Let's say person A saves it first and person B saves it second. Whose changes will be lost? Well, person A will, because if person B saves it second, it will override all the changes of person A. You can't have that with a database. I need everybody to be able to add instances or records into the database in real time without interrupting or obstructing each other. So the difference is an Access database is edited directly on your hard drive, whereas an Excel or Word doc are edited in your computer's RAM and then saved to your hard drive. So it's saying give it a hard drive space right now, not a problem. Let's make this, let's call it orders, or order processing system. You can call it whatever you want though, I don't care. Put it wherever you want, just go ahead and create that thing. Immediately it has placed this database now on my hard drive, which means that anyone who adds rows to it will be adding them directly to the hard drive. Whereas with a Word doc or Excel, when you make a new one, it's all in your RAM. It doesn't exist on your hard drive yet. So changes get made in RAM, they get edited in RAM, and then as soon as it's saved, it's copied from RAM back to the hard drive. So because we can't have that, we've got to create the file first so that all changes can be saved directly to the hard drive immediately. Alright, so here's what we've got. It says Table 1. Now, Access has many types of objects that can be created. We're going to work with tables only for now, and then in the next chapter, in the next class period, we'll move on to queries. But there's other things we won't learn or get into. You can create forms, which are basically nicer looking ways of entering data than simply editing it or adding it directly to a table. Reports are also something you can create right here in the Create tab. We've got tables. This is what we're working on now. Forms. Reports are a way of when you need to analyze or aggregate data or look at the data, rather than just look at a regular table view, you can sort of pretty it up, you can summarize data, you can make it look however you want to give it to management. So forms and reports are great tools for entering and then viewing data, but we're not going to get into them in this class. These are common tools that you'll find in every database management system. They're pretty standard, but for now I want to focus on creating the original tables and then writing queries to pull data out. This is one of the most useful things, but we'll wait and talk about that later on. For now, let's just worry about tables. So it's given us a field here called ID. It's guessing, it knows we need to have a primary key, so we're going to give you something called ID, and then it says now add another field. I don't particularly like this view. We can use this and we can sit here and add more and more fields. I can change ID to something else. I can change the name to customer ID or something like that, or customer number. But what I prefer, and this gives you just a traditional table view, what I prefer is this design view. So I'm going to click on Table Tools. So this is my context sensitive tab here. I only see this when I'm working on a table. Come over here to View and change it from Datasheet View to Design View. Oh, it's mad that I deleted the word ID. Okay, I get it. No problem. We'll put ID back there. And now let's go ahead and change to Design View. It says, first of all, you've got to save it to the hard drive, because if people start adding data to it, it needs to be on the hard drive. Okay, got it. No problem. Let's call this. We're going to basically mirror what we did in with the ERD. So when we create tables in a database system, we start by looking at the ERD. It's best to begin with this because that's how we make sure we get it right, rather than try to just create tables on the fly. So let's start with customer. Over here we called it account number, but well, you know what, that's fine. Well, let's start with calling it the customer table. Save. Now what it's done, this is the design view. It's taken those columns that were across the top and it's rotated it 90 degrees to where now the columns are down the rows here. So it says here's your first field name in the database table. Let's call this account. It doesn't like us to use symbols, at least we shouldn't, so I'm going to change this to account. Alright, we'll call it account ID. Let's start using that. Okay, next thing that's different from Excel, you'll notice immediately, is it says we want to know right now what the data type is. So in Excel, yes, you can go in and you can edit data types. For example, right here I can say this data is of type date, or it's a year or something like that. Or I can come here and say this is, instead of general, this is text. But it's not something we have to do, right? Excel will make it what's called a general data type, and it's only for formatting purposes. In a database, the data type has a much more important significance. So, as I've alluded to before, your instructor may have mentioned in class, data numbers are stored differently on a hard drive than text is. In particular, numbers take up far less space in a database than text does. The number 1 takes up less space than the letter A. Why? Because there's only 10 numbers, right? Whereas there's 26 letters, and that's only lowercase. Double that for uppercase. And actually, if you include all possible characters on the keyboard, there's actually 95 possible characters. So what a database does, it says, okay, if you're going to make this a text field, then we have to store 95 possible bytes for every character in this database field. Whereas if it's a number, then we only have to store 10 possible bytes for every character in this field. So it's able to format the way it stores characters differently to save you space. So whenever possible, you want to not use text and use numbers. Date times are sort of in between. They take up less space than text, but more space than numbers. The best by far Access calls it a yes/no. Really, it's better referred to as what's called a bit. A bit is the smallest possible increment of space on a hard drive, and that means a bit can have only two values, 0 or 1. So if you've ever heard the term, it's all zeros and ones, or binary refers to the fact that every little cell on a hard drive can only have one of two values, 0 or 1. And every character is made up of a combination of zeros and ones. So the smallest data type is yes/no. And it actually turns out this is quite common. What are some data types you'd use as a yes/no? Well, I'll give you an example here. First of all, account ID. Auto number is a special version of a number that will automatically increment and be entered for you every time you add a new record into this database. So you'll see what I mean. Let's leave this one as auto number. Now if we want to, we can come over here and add a description. This helps for people who are editing the database later to know what you meant by this field. Some of our field names get kind of scary and difficult to understand, and so descriptions are useful if it's not obvious what's being stored by the field name and data type. Let's go on to first name. Whoops. What is first name going to be? Well, clearly it's going to have to be text. Difference between long text and short text is the number of possible characters you can have in the field. Notice here when I enter short text, I have all these other properties for the field. Field size, 255. Whether we use that space or not, Access is going to store or reserve 255 characters of space for the first name. All right, we're never going to need that. So to save ourselves space, let's limit first names to a possibility of 20 characters or something like that. Format. These are very useful things that help enable database validation. Sorry, let me cancel this. I don't want to do that right now. There's a default value. If I don't enter in a first name, what should we put in here? This is useful for things like, say I've got a field for state, and someone doesn't enter the state in, but my business is only located in the state of Texas, so I'm going to default that value to TX or something like that. Validation rule, just these are ways of making sure that whatever I enter in, for example, an F name, let me come back to this. I'll have a better example for you later. For now, let's go on to L name. Also short text, that makes sense. Let's have gender here. What data type should we make gender? You might think short text, so you could put in female or male. But how about instead we put yes/no? Because gender is only going to be one of two values, we can use the tiniest possible data size to represent that. And then I'd come over here to description and say yes equals female, no equals male. So it's a way of keeping our database small and using data types to our advantage. And here's where a description makes sense. You really need this if you have a data type that doesn't make sense semantically for what you're trying to represent. All right, gender. What else should we store for customers? Email. So here's where we can use a validation rule to help us out. So an email has to have certain characters in it, right? So watch what we can do. I'm going to click here on validation rule and click on these little dots. And I have a series of functions. All right, these are functions much like the Excel functions you've learned before that I can use to validate whatever they put in the email field. So I've got ways to convert data, date time functions. Let's go down to text. So you may not have learned these in Excel before. Some of these you'll learn when you go through VBA later in this class. One that I like is this one right here, in str. This is a function that checks to see if something is in the string. So for this function, we pass in where we want to start in the string, and that's optional. That's why it's in brackets. So I'm going to ignore that. The string itself, which is going to be whatever they enter into the database field, the string we're looking for, and then what we want returned. So in particular, what I want is in string, we're going to start at character 1. The string itself is going to be whatever they enter into the database field. Well, the name of the database field is email. In fact, I think I need to put that in brackets. Whoops. There we go. String match. The string I'm looking for is the @ symbol. Oh, so this function returns. Well, let me show you here. I'm going to go ahead and compare is optional. So inString returns the number of the location in a string that a string is found. So in other words, it says it looks at whatever they enter for email, and it's going to return a number that says where it found the character at. So if I say if inString is greater than 0, what that means is, if it were to return 0, that means that it couldn't find the @ symbol anywhere. So as long as it returns something greater than 0, that means it did find the @ symbol. So let me show you how this is going to work. I'm going to hit OK. I'm going to save this, and let's go ahead and enter some data in. So back here, remember, I'm not going to enter anything in for customer ID because it's auto number, meaning the second I type H for Homer, it automatically puts the lowest integer it can find that's greater than 0. Homer Simpson. We made yes female, so I'll leave that unchecked. Whenever you make something a yes no, it gives you a checkbox here. So email, let's say we enter in Homer and we go on. It says, whoa, one or more values are prohibited. It's this big ugly error message. We can change this error message too so it makes a bit more sense. But essentially it's saying we couldn't find the @ symbol. Okay, thank you. Homer at Simpson.com. Now, there we go. Now it accepts it. That's what we call a business critical integrity constraint. It's a constraint that does not let me enter data in unless it's clean and accurate. Now, is that perfect? Absolutely not. Someone could still forget the .com. They could make a typo entering anything else in, but it's just going to make the data that much cleaner and more likely to be good. So, let me enter in another one so you can see how auto number works again. Marge, see how it automatically, it recognizes a number 1, automatically puts a number 2. So let's move on. Let's say, though, that we delete Marge and come back. And we try to enter in Marge again later on. Notice how now she's a number 3. See, it remembers what's been used in the past. And it does that intentionally because let's say we deleted a record that had orders attached to it, but we didn't delete those orders. Well, we're going to want to remember that those orders were replaced by someone who's not currently in the database anymore. So it's smart enough to know not to reuse numbers when it's set to be an auto number. All right, Simpson, female, Marge, at Simpson.com. That's enough for now. So if I go back here to design view, anything else we want to enter in here? You know, that's good for now. Let's leave it. Okay, that's our customer table. We should add a couple more in, though, just to be safe. Bart, Simpson. I'm going to ignore email for now. Lisa, Simpson. Oops, female. Maggie, Simpson. Okay. Now, something else you'll notice. This row, as long as my cursor, if I haven't left this row yet, Maggie Simpson actually has not been saved to the hard drive. So, like I told you before, many people can be entering customers in this table, and it will keep track of the auto numbers and everything just fine. It doesn't save or commit something to the hard drive until I leave this line. So if I were to hit escape right now, we'd actually lose that line. But if I hit escape again, it doesn't lose or delete anything else because those have all been committed to the database. So Maggie, oh look, it also, just in case, incremented Maggie to number 7. All right, that's good for now. Let's make our next table. I'm going to close this one out. Let's add an orders table. So I'll go to create table. Let's go to design view. We'll call this orders or order. Okay, let's make an order ID. Let's make an order date, and now we get to make something using the date type. You'll see what that does a little later. Oh, I forgot to show you a way to change that ugly, go back to custom real quick, design view. I forgot to show you how to change that awful validation text we got. Right here, next to validation rule, let's change this to you forgot to use the @ symbol. There we go. That's the text we want to see. So let's go to let's save the table, go to the datasheet view, and add somebody else. Sideshow Bob, or we'll say sideshow, and then try to leave. There we go. You forgot to use the @ symbol. It's a nicer error message, that's all. Bob.com. Anyway, close that customer table out. Back to orders here. We have an order date. Let's have a total. This is going to be a currency data type. Let's have a payment type. Now, payment type. I could write in Visa, check, cash, those things, but I'd way rather use numbers here to keep my database smaller. So how about instead I make this a number, and then I say 1 equals credit card, 2 equals check, 3 equals cash. Then I just use those numbers when I put them in here in payment type. This is a very common practice to save space. All right, that's good for orders. Let's close this. No, I'm going to switch back to datasheet view and save it. And let's go ahead and put some data in. Now, before I do that, stop and think, am I missing anything in the orders table? Well, go back and check the ERD that we created. That's our source of information. Yes, I did. I forgot account number, the foreign key from the customer table. Okay, I can't forget that. Let's go back to datasheet view or design view and add, what did I call it? Did I call it, let's stick with account number though, because I want to show you that it's okay to call something a different name. Account number, and we'll make this a number. And I'm going to put a description. This should match the customer ID. All right. Perfect. Before I put any data in though, I'm going to save this one and make everything else, and you'll see why in a bit. Okay, that's order. Let's create another one. Table. We know we need, let's do order line item. Okay. Fields. Go to design view. Order line item. Okay. Let's make this order ID. And we know we're going to need, what else here? Order number and product number. All right, no problem. Order ID, and I'm going to call this product ID. These can't be auto numbers. These have to be regular numbers because these are foreign keys that get pulled from other tables. So we can't make them auto numbers. Also, this little symbol right here says that it thinks order ID is the primary key, which is also marked right here. I'm going to deselect that and turn off primary key, and instead click and drag and select both of these and click primary key, so that it knows that together these are a composite primary key. Okay, the other field we need, quantity, so let's add that on. Quantity, also a number. This is good for now. Let's save it and close. And now let's make the products table. Create table, fields, design view, product ID, auto number. We have a name. Okay, I'm glad this came up. The name you supplied, name, is a reserved word. Reserved words have specific meaning to access in database engine. If you reserve it, you might get an error when you're using this field. Okay, good to know. Let's change this to product name. That's better. And then we have a product price, maybe a, we'll call this currency, maybe a quantity on hand, something like that, number. Okay, save that, close it. Now, before we put data in anything here in product or line item or order, I want to use a different tool called the Relationships tool. Here under Database Tools, click on Relationships. And it says, okay, what tables do you want to create relationships for? So this is just like we did in Lucidchart. Select all those or double click them. I can double click on any one of these things and bring them out. Or let's say I close that and I forgot to include product. I can just click and grab product from out here, drop it in, not a problem. Okay, so we need to start drawing some relationships so Excel knows there's a relationship between these. This is a very important step because it's going to let Access create an actual electronic relationship which will be useful later. Let me stop right here. I'm going to save that, yes. I'm going to open customer. Open order line item, open product. I'm going to add a few things in here. Product name, football, 30, I have 100 on hand. Baseball, 10, I have 300 on hand. Basketball, 40, and I have 50 on hand. Okay, let's go to order, notice now that I've created this as an order date, it gives me this nice little date picker. So 11th, order total was $100. Payment type, let's say they put it a credit card, so it's number 1. Account number, let's say Homer bought this. Okay, order 2, 19th, 20, payment type you paid with, I don't even know what number 2 was, I've forgotten, that's okay. This was by Marge. Let's make another one by Homer. On the 12th, for 40, payment type 1 again, account number 1 again. Okay, close all these out. Now that we've put data in. Whoops, I forgot to put data in order line item. I better take a look at that because I need to make sure these things add up. Order line item, we have order 1, which included, we'll say we're just making this up, let's say it included football, one of those. So if he spent $100 on his order, that means that was only 30. So order 1 also included baseball, and he bought 7 of those. That gets us to 100. Order 2, Marge bought a basketball, bought 1 of them. Her order was 20, so never mind. I guess she bought baseballs, and she must have bought 2 of them. Order 3, Homer bought, what was order 3 for? 40? He bought 1 basketball then. We'll say basketball 1. Okay, now we've got all of our data here. Close those out. Go back to database tools, relationships. Okay, there's data in here now. So when I draw relationships, certain rules have to be followed. For example, customer ID is called, the primary key is customer ID here, but we named it account number over here, which is supposed to represent the primary key from customer ID. It's okay for them to be named different names. I'm just going to click and drag customer ID, drop it to account number, and it says, okay, would you like to enforce referential integrity? What does that mean? It means that every record in the orders table for account number, whatever number I put here in account number, there must be a corresponding customer ID that it matches to. This is another business critical integrity constraint. It's a way of making sure that my data is good. I can't enter an order assigned to customer 12 because there is no customer 12 and then my data is bad. So I check enforce referential integrity to make sure that it doesn't allow me to mess up. Cascade and update and delete, these are useful, but be careful in using them. What this means is that if I were to change a customer ID in the customers table, it will automatically update all corresponding account numbers to match that customer ID. I'm not going to do that for now, but that is useful in some situations. Okay, here we go. Data in the order table violates integrity rules. Meaning, for example, there may be records relating in the related table, but no record for employee in the primary table. Edit the data so that there's no rules broken. Okay, let's close this out. Let's open up customer and order. All right, here under account number, I have account number 1 and 2. What could be the problem there? Well, come and check. What's the problem? There is no customer 2. Remember how we deleted Marge and entered it again and it auto-incremented up to 3? I can't have customer or account 2 right here. Let's change that 3 to Marge. All right, close that out. Yes, save it. Close that out. Try it again. Customer ID to account number, enforce referential integrity, create, and it's happy. All right, look at this. We've got a relationship created, but it's using different notation. This infinity symbol means many, and this number 1 means that tick mark. So this is just like we had it in Lucidchart, where it's a tick mark and crow's feet, but it's just a slightly different notation. This is common. Everybody uses a little bit different notation, but they all mean the same thing. Okay, let's go to the next one. Order ID here matches up with order ID here. Enforce referential integrity, create. Product ID here matches with product ID here. Enforce referential integrity, create. Let's save this thing. Okay, we're all good. Let's close this out. Now, because I added those relationships, it's going to do something kind of cool. What do you see now here in the customer table that you didn't see before? Before, when we had it open, we didn't have these plus signs right here. What are these for? We'll click on them. Notice it says, now what it does is it's gone to the corresponding orders table and it's pulled up every order that was placed by customer ID 1 by Homer. And it doesn't include account ID in here because it knows all these records are assigned to Homer. No need to include that field. Kind of cool. Here's Marge's one and only order. Bart and Lisa haven't placed any orders. So we can actually enter data here if we wanted to. But this is cool. I can also break this out and see on that order what were the products that were included. Product 1 and 2. So the data is tied together now in an actual relational database management system. Very useful tool in Access. Good luck on the next chapter.